Okay, a player pitches a baseball horizontally, so it will go horizontally. So what are the forces applied to this ball? mg and the friction of the air. Instead of the friction of the air, since it is very complicated to compute those frictions, the question gives you the drag force, aerodynamic drag, which is this. And it is called horizontal. We also have vertical, and in this question we don't have it here. So it is called CD, which is a number 0.3, 1/2 half rho density of the air. You need to memorize the density of the air, which is 1.2, and also the velocity of the ball, and S. What is S? S is the cross section of the ball. Here, let me show you something. So this is the ball, okay, and this is the air. If the ball is going this way, the cross section of the ball relative to the air is this, which is pi r squared. So in the question they gave you the circumference, which is 2 pi r. 2 pi r is equal to this number. So you need to find the radius first, and then after finding the radius, which is 0.232 over 2 pi. This is radius, this number. And then you need to find the pi r squared, which is S. Okay, S. So D is a function of velocity. Remember. Now you need to remember we have, as I said before, acceleration is a function of, can be stated as a function of velocity at time, velocity of s, distance and time. So in this question it will be stated as a function of velocity and this distance. So I will use this formula, and the only force that applied to the ball in the left direction is the drag, because the friction is always opposite to the direction of the velocity. So it will be minus CD 1/2 rho v squared s equal to mv dv over dx. So then the integration, the dx goes to this way, all of the v will be on the other side. So we have v squared, we have v, so when v squared comes on the denominator it will be 1 over v. So here we just have s. So integration of z from 0 to x, from v0 to v. Y from 0 to x. So we assume always this point is x equal to 0 if the question didn't tell us anything, and at this point, when x is equal to 0, v is equal to v0. Because of this we put here v0. Remember 0, v0, and at x it will be, the velocity will be equal to v. Now let us find the integral of this part. So integral of 1 over v dv will be ln v, from v0 to v, it will be ln v minus ln v0. So we will use the logarithmic property of ln a minus ln b is equal to ln a over b. So the integral will be equal to this. So now we need to get rid of the ln. Because of this we need to use the exponential formula, and you don't see any ln here because here we find the exponential of this term and exponential of this term. But m first should be on the left hand side. Okay, here on the right hand side there should be just ln. Because of this we put m here on the left hand side. M will go to the denominator, and the final answer will be v equal to v0 e exponential to the power of this. So, and then instead of x, sorry, we have the v0, and instead of x we will put 18 meter. We will find the v velocity, because this velocity is a function of v0 and x. Now we need to find the time. Assume that the velocity is constant. We know that you might ask, okay, the velocity is not constant. Yes, you are right, but assume that the velocity is a constant. Assume that it is v0, okay? So the time will be equal to, for 18 meter, it will be this time. And then the vy will be equal to 4.24, okay? So the magnitude of the velocity will be this number. So if we don't have a friction, the velocity obtained from this formula. If we have a friction, it will be obtained from this formula. Obtain this number and compare it and let me know.